Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-5 Extra Practice Number 1 solutions on rational equations. On this one, we want to know which of the following numbers represents the sum of all the possible solutions to this equation. So basically, we have to solve this equation and then add all the answers together to get one of these answers here. All right, well, since these both have a w plus 6 in the denominator, the least common denominator here is a w plus 6. So I'm actually going to take that LCD and multiply everything by that. Now, my other option would be to cross-multiply with these w plus 6's, but that's just going to make more of a mess. If I multiply each of these fractions by w plus 6, that will actually cancel those w plus 6's out completely, which is a much nicer situation. So that leaves me with an 18 minus 3w on the left side, and this is going to be a w squared on the right side. Now I'm going to go ahead and rearrange this. This is a quadratic, so let me zero this out so I can either factor or use quadratic formula. So we've got a w squared. I'm going to keep that over on that side. Then I'm going to add the 3w, and I'll subtract the 18, and that'll leave me with 0 on the other side. So this looks like I could factor it. I need numbers that multiply to negative 18 and add up to 3. Let me see here. We've got negative 3 and positive 6. That would do the job. So we have w minus 3 and w plus 6. And then if I zero each of those parentheses out, I get w equals 3 or negative 6. So I needed to add the answers together, and it's awfully tempting to add these together and get negative 3 and select answer choice B. However, before you do that, this is a rational equation. This has fractions, which means denominators might be able to be 0. So we have to check our answers and make sure that neither of them gives us 0 in the denominator of the original equation. 3, if I plug that in here, 3 plus 6, that's totally fine. But negative 6, if I plug that in, negative 6 plus 6 is 0. Since negative 6 makes the original undefined, this is an extraneous root, an extraneous solution. We have to cross it off and not use it. That means that 3 was actually our only answer. So the sum of all the possible solutions is just this one, 3. So that means that we actually have answer choice C to pick at the end of this one. For this problem, they're telling us that m and n represent solutions for this equation, and they want to know what happens when we add those together. So we're going to have to find the solutions to this thing and add them together and hope for the best. To get this thing started, there's a few ways you could go about this. Probably the fastest is just going to be to cross-multiply to get rid of the fractions. So we can have x plus 2 getting multiplied over times the x here, and then 2x minus 1 times 2x plus 1. Those will get multiplied together. Cleaning things up a little bit now, we have to multiply things out. We have an x squared plus 2x over on the left if we distribute. On the right side, this is the same terms with opposite signs, conjugates. So we can use our a squared minus b squared shortcut for multiplying those. So we'll have the first thing squared, the second thing squared, and a minus in the middle. So 4x squared, and then minus 1. Cleaning things up a little bit further now, I'm going to try to get everything over to one side so I can either factor or use quadratic formula. Now I'm going to get things over to the right side because then at least I'll have a positive x squared. So we have 4x squared minus the x squared coming from the left side there. That's 3x squared. I'm going to subtract the 2x to get it over there. And the negative 1 is already there. So at this point, I either need quadratic formula or factoring. And I think I'm going to try to factor this. This doesn't look all that bad. I don't like things that have an x squared with a number other than 1 in front of them, but every now and then it's okay. Like 3 is a prime number. The only way to get 3x squared is doing 3x times x. 1 is also pretty easy. I need a positive and negative 1 to multiply to get that. So I have a 3x and an x. I just have to figure out which one gets the plus 1, which one gets the minus 1. So I'm just going to throw one out there and hope for the best. Let me try 3x plus 1 and 3x, or actually x minus 1. And let's see if this works. So if I do 3x times negative 1, that's negative 3x. 1 times x is negative x. negative 3x plus x does give me negative 2x. Hey, I got it on the first try. Lucky me. Now I'm going to go through and zero out each of these parentheses to get my answers. So for the first one, if I subtract 1 and divide by 3, that's negative 1/3 for x. And then x equals 1, we'll zero out that second parentheses. So at the end of this one, I need to do negative 1/3 plus 1. Well, that's really negative 1/3 plus 3/3, which is going to give us 2/3. So that's answer choice C. On this problem, we're given this rational equation. We're told that t is a solution to the equation. T is positive, and we want to know the value. So right away, just looking at this multiple choice selection here, we can eliminate choice A because negative 5 is not greater than 0. We can also actually eliminate choice C. 0 is not greater than 0. So this is actually not so bad. It's either down to 5 or no solution. So I'm going to go ahead and let me just solve this normally, but just keep in mind that you already could have eliminated 2 out of those 4 answer choices. So to solve this legitimately, we need to multiply everything by the LCD to get those t's out of the denominator. So the LCD is going to have everything I need to cancel out each of the denominators. So I'm going to need a 4, a t plus 1, and a t plus 3. And I'm going to go through and multiply each of my fractions by this LCD, and it's going to be in the numerator for all of them. So we have first fraction times the LCD in red there, equals second fraction times the LCD in red, plus 1/4 times my LCD. All right, so now I'm going to go through, cancel out some stuff. T plus 1's cancel in that first fraction, then it's the t plus 3's, and then finally it's the 4's. I have a whole lot of cleaning up to do, but at least my fractions will no longer be fractions. So for the first fraction, I have a 4, a t plus 3, and a 3. 4 times 3 is 12, so I'm really just distributing 12 to t plus 3. That's going to be 12t plus 3 times 12, 36. In my next fraction, I have a 4, a t plus 1, and a 2. 4 times 2 is 8, and then distributing 8, we have 8t plus 8. And then finally in this last one, I have t plus 1 and t plus 3, so I'm going to have to FOIL that out. So a whole lot of stuff to do there. First gives me t squared, then outers is going to be 3t, inners is 1t, and then the last is 3. All right, let's do some more cleaning here. A whole lot of simplifying. I'm going to keep the left the way it is for now, but don't worry, I'm coming back to that. On the right side, I'm going to combine like terms. So we have a t squared, nothing to combine that with. Now the t's, we have an 8t plus 3t plus 1t. That's a total of 12t. And then we have an 8 and a 3 that can add for 11. Going a step further now, I was actually about to move everything over to the right side, but I happened to notice that I have a 12t and a 12t that once I subtract 12t, those actually just go away completely. So I'm left with just constants and a t square. In that situation, I just like to get the constants on one side and the squared term on the other and square root it. So if I subtract 11 from 36, that gives me 25 on the left. I still have a t squared on the right, and again, I subtracted 12t from both sides, so that's not a factor anymore. So now if I square root both sides, I would normally get plus or minus 5, but they told us that t is positive, greater than 0. So I'm only going to keep that positive root of 5. Now double checking to make sure that doesn't make anything undefined. If I plug in 5 for t into the equation, 5 plus 1 is not 0, so we're good there. 5 plus 3 is not 0, still good. So because that doesn't make anything undefined, 5 is in fact our final answer, choice B. For this problem, we want the solution set for this equation here. So we've got combinations of 1s and 7s and negative 1s and negative 7s. So to get to the bottom of this thing, we're going to try to get rid of those x's in the denominator by multiplying everything by the least common denominator. So the LCD has everything I need to cancel out my denominators. So I need an x plus 7, I need an x minus 7, and before I go ahead and throw x squared minus 49 in there as well, x squared minus 49 actually factors into x plus 7, x minus 7. So that's just another form of the denominator here. So this LCD actually does have everything we need. Now that I've got that, I'm going to multiply each of my numerators by the LCD. So first fraction gets an LCD upstairs, minus, we have a 3x times the LCD over the x plus 7, x minus 7. And finally, we have this negative x squared plus 4x multiplied by my LCD. And I'm actually, while I'm at it, just going to factor x squared minus 49 into x plus 7, x minus 7, just so there's no doubts what I'm really dealing with down there. Okay, going through and canceling out what I can. The x plus 7's cancel in that first fraction. In the second fraction, it's actually both things, x plus 7 and x minus 7. Hey, the less the merrier. And then in the last fraction, again, we're canceling both of those 7's. So let's see what we have now when we clean things up. In the first fraction, I've got an x minus 7 times 1, so just x minus 7. In the next fraction, all there is this 3x. Careful, though, because we are subtracting that whole fraction, so minus 3x. Equals, here I just have the negative x squared plus 4x all by its lonesome. I've got a quadratic going on now. At this point, I'm going to move everything over to one side and hope that I can maybe factor it or use a quadratic formula. I'm going to move everything over to the left because that's going to end up giving me a positive x squared. So adding x squared over to the left, and then let's see here. We've got an x that's already over there minus a 3x. That's going to be negative 2x. But now if I also subtract the 4x from negative 2x, that's a negative 6x. And then I still have this negative 7 just hanging around. All that equaling 0. So now I need numbers that multiply to negative 7 and add up to negative 6. I'm thinking positive 1 and negative 7, so x plus 1 and x minus 7 equals 0. Which means, if I zero each of those out, that x equals negative 1 and positive 7. Or does it? Remember, we have to go back and check this to make sure we're not zeroing out any denominators, making things undefined. Negative 1, if I plug that in, negative 1 plus 7 is okay. Negative 1 minus 7 is okay. Negative 1 squared minus 49, still okay. But now if I plug in 7, we see that there's two places, right here and right over here in this denominator, where plugging in 7 gives me a 0 in the denominator, making things undefined. Because 0 makes the original undefined, I have to actually cross it off. It's an extraneous solution, and the only real answer is negative 1, which means choice A is my answer, not choice B.